All right, hi everyone. In this video, we're going to kind of get a different angle, and what we're going to talk about is how to graph density. Now, this is page 5 on in our Unit A packet, and let's graph object A together. So as we read through our directions on page 5, we can see that volume goes on X, and mass, therefore, is going to go on Y. So I'm going to go ahead and just adjust my camera here so you can see my graphing. Let's move that cord a little bit out of the way. Good, good, good. Okay. So mass has to go up to 50 somehow on my graph. So I know I got to start at 0 down here. I need to label it mass on my Y. I put the unit in grams. Volume is going to go on the X. That is milliliters. Notice I label my axes with the correct unit. And I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Goes up by 20. I'll go up by, not quite 2s. I could do 2s. 2. Okay. 10, 12, 14, 16, 18, 20. 30. 40. Good, good, good. And volume needs to go up to 30. I'm going to go by 2s as well. 6, 28, 30. Okay. So I decided with my graph paper to go up by 2s. You might want on your paper to go up by 1s. And let me graph my data for A. So starting with 0, 0. And then my next point, mass, volume is 5. Mass is 5.50. So 5, 5.50. And then for my next one, the volume is 15. 12, 14, there's 15. The volume is 15.18. 10, 12, 14. Okay, really close to 16 there. And for the final one, the volume is 30, and my mass is 34. So that's 30, 32, 34, a little bit above there. Okay. So again, I counted off my axes. I put mass on Y like it told us to. Volume on X. I labeled them. I counted off by 2, and I plotted my points. And notice it says I can't use a break in the scale. So I just labeled all of these points by 2. Again, you can do something a little bit different on your paper. I like to go in by 2. And again, you can see how I labeled my 2 axes. I decided to go by 2s because that would fit all my values on the graph. I couldn't break anything. I couldn't skip anything. And now as I look at what's next on page 5, it says to draw the line of best fit. So a line of best fit means we need to take a ruler. It should definitely go through 0, 0. So a line of best fit means we kind of want to take that arrow out so that it kind of goes through or really close to our point. So if you notice kind of how I have it set, it kind of goes above and below our 4 points for object A. So I'm kind of approximating what a straight line would look like with my data. And it's got to go through 0, 0. Again, line of best fit has to go through 0, 0. So I draw my line of best fit. Little wonky there at the end, but it's okay. And it says title, I'm just going to go mass versus volume. And now it wants me to do the slope of each line. So to do the slope of each line, we want to pick 2 points that are on our trend line. And we don't want to use actual data points. The whole reason we do it this way is it eliminates error from data we've collected. We don't want to use 0, 0. And it looks like it crosses exactly here. So that would be 20, 20, 22. And then it also looks like it crosses exactly there, 2, 2. So now we want to find the slope. y2 minus y1 over x2 minus x1. So now if I'm finding the slope of my object, 22 minus 2 over 20 minus 2, that's going to simplify to 20 over 18, which when I do my math, I get a slope of 1.1. And if I pay attention, my units would be grams over milliliters. So we just found density. So again, I know that was pretty quickly, or done pretty quickly. So mass on y, volume on x. I plotted my points. And then remember, I did my line of best fit, where I kind of looked at points that I'd collected, and I drew a straight line that did the best to kind of average out those values. And again, that line of best fit has to go through 0, 0. Then once I draw my line, I picked up 2 points that were on my line of best fit, not my original data points. And then I did rise over run to figure out the slope, which is the same as the density of our object. See if you can do object B and see how it goes.